Okay, this is the 2-5 notes, measures of position. So we're going to look at, sorry, I had that on the wrong page. Okay, we're going to look at quartiles, we're going to look at interquartile range, and we're going to look at the box and whisper plot. So quartiles are basically when we're putting our data in numeric order, we're cutting it into groups of 25%, 50%, 75%, and 100%. That's what quartiles is representing. The first half, the middle, and the first third, 3/4. So our first step is the same thing as doing the middle. Q2 is the same thing as the median. Okay, so that is, we would find the median first. You're always going to start with that. First, put your numbers in numeric order. There were 12 of them, so we count in 6, and that gives us 2 different possibilities. We divide that by 2. That is our median. Okay, so Q2 is also the median. Then we cover up the left-hand, right-hand side, and we do the same thing. We repeat the process. Count in even numbers. They end up on 2 different ones. Divide by 2. That's the quartile 1, or the first quartile, which is the 25% area. Okay. Then we cover up the left and do the same thing for the right, which is the third quartile. And that is at 75% of the data. So up to that point is where 75% of your data is. Okay. Now we need Q1 and Q3 to be able to do the IQR. IQR is the interquartile range. We call it IQR because it's really a lot of words on our mouth. But it's basically similar to a range, except this time instead of finding the max minus min, we're going to do the 75 percentile minus the 25 percentile. So the Q3 minus the Q1. And then, so it's basically the same thing. You find your middle, you find your Q1, you find your Q3, and then we subtract. Okay. You do need to know how to find an IQR. That is like a big part of what anytime you're doing any kind of project for me or for Miss Pierce, you will have to have the mean, the median, the mode, the standard deviation, the range, and the interquartile range. Now, what do we use that for? Well, it's a big part of creating our box and whisper plot. So we have found, we know what our minimum is, we know what our maximum is, and that helps us to figure out our range. We find our median, our Q1 and Q3, and our interquartile range. The interquartile range is the distance, it's how long this box is. That's what that actually is. So I'm going to write that in here so that we can see. AQR is the distance from left to right inside the box. Range is from here to here. Maybe that'll help to keep it straight in your head. Okay, so these 5 numbers, the minimum, the Q1, the Q2 or median, Q3, and the max are what we call the 5-number summary. Every time you do some kind of a reporting, you want to give those numbers because it gives the readers an indication of what your data range was and important pieces of information about your data without telling them the actual data points. Okay. And the box and whisper gives us an idea of what the data is doing before you actually put it into a bar graph. We can see that this is skewing to the left because we have a big tail going here and everything else is over here. Okay, so this actually goes back to that skewing thing. So if I was drawing these as bars, I would have had a whole lot of tall bars over here and itty bitty little bars over here, and it would kind of have gone like this. So you can kind of see like it doing something like that. See how it's skewing down this way? So it gives us an information without actually having a different type of data showing that information. We don't actually see our data. We just see the most important pieces of it, the minimum, the maximum. The first 25% is in this first group. From here to here is 25%. From here to the median, which is Q2, is 50%. To the Q3 is 75%, and 100% of the data goes to the max. Okay. All right. So we can also break it up into other groups. You can do it decils, which is by grouping with 10 parts, basically 10% each percentage, or you can do it at different percentiles. Okay. The same kind of concept would be involved, where you would actually just identify what percentile, and you're going to be doing your data looking at breaking up into different groups. So it could be every 20, instead of 25% quartiles, it could be 10%. Or you would want to keep them even, like every 20%, that kind of thing. Okay, the last thing we need to look at, and this is like one of the most important things to know how to do because we will use it all year round, is finding a Z-score. And that is found by taking the value that you're looking at minus the mean of the prior information and dividing it by the standard deviation of your testing situation. Okay, so we have a statistics test has a mean of 63 and a standard deviation of 7. So we all took a test. The mean was mean grade was 63. Average grade in the room was a 63, plus or minus 7 points. So some people got closer to the 70s, some people got closer to the less than 58, 56. Okay, so that's the first group. That's that first 68% was in that first grouping from like a 58 to a 70. Okay. Now we want to look at one single person's situation. Well, they made a 75, so we want to see where they were in relationship to all the other kids. So we're going to do 75 minus the average from the class divided by the class's average, standard deviation, and that gives us what's called a Z-score. A Z-score is used in math to be able to equalize information. So instead of looking at apples and oranges, all the data is now in the Z-score form, meaning that it's all apples. You're comparing like to like, not different type of information. For instance, biology test. The biology grades on a different scale, maybe a 30-point scale, because their mean was a 23 and their standard deviation is 3.9. So they made a 25. Well, is that a bad score? Well, let's find out. We do 25 minus 23, their score minus the average class score divided by the standard deviation, and they made a 0.51. So which test did they technically do better on? The two tests were not scored in the same way, but now that they're both Z-scores, we can say, well, they definitely did better on their statistics test than they did on their biology test. They were in the top, they were in the B range, because remember that graph? Remember that graph where I said, okay, that first, this is my C's, this is my B's, and this is my A's. At 1, between 0 and 1 is a C grade. Between 1 and 2 is a B grade. So they made a 1.71. So they got a B on their statistics test, but for their biology test, they got a C. So this would have been like a C grade, and this would have been like a B grade. If that helps you to understand how you're comparing them, that should help. It does the same thing when it's on the negative side, but remember how negatives work. The bigger the number on the negative, the smaller it really is. So when you're thinking about negative numbers, so if you're on the other side of this graph where you're at that -1, -2, -3, remember that -3 is a smaller number than -1, okay? Meaning that they're getting better the smaller the negative looks, okay? If you have any questions, please let me know.